Well, basically, I think we are going to take this presentation pretty much like the foundation for everything else that you will see during the day. And what I would like to really do is something that, according with progress with this different presentation, you will understand what is actually the architecture that it have been followed to import information to the different Sigmafine that many of our clients have, and how that data improve their information and the way how they take decisions. So in just in a glance, whatever we have here is pretty much what is really associated of how we are going to get that information and what are the best practices that we have. They say, I will go a little bit in the discussion of this engineering data for the digital transformation, and I will present somehow the pillars where the integration is founded. And from there, we will go taking a little bit the steps that we have and the different ways to import data to the Sigmafine in a way seeing the architecture, what the integration framework has, that is our tool for integration of different external systems to Sigmafine. And I will present some brief cases where our clients have used the Sigmafine to import information to their system and what are the benefits that they have had. Well, basically, one of the most important parts in the engineering data for digital transformation is pretty much what is that information and how that information can be taken to our systems. But I will say that there are several steps that we need to follow and some details that we need to pay attention. And I will say that we have divided that in 5 different areas. The first area is actually looking to implement a way that the data from the peripheral elements or equipment systems that we have in the around the Sigmafine can be collected to Sigmafine. But I will say one of the most important part here is also keeping in mind that we have an heterogeneous systems, that we may have different type of data sources. We can have those systems with different naming conventions. So one of the first part that to do is pretty much to have an homogeneous master data element. So we need to aggregate all that information to have it in a way that our system is able to translate whatever is in the other system. And I will say the second part is also one of the most important parts is the skills of our teams. They say we need to make aware everybody how that data can be, I will say, taken and what is the progress that it has. Because at the end of the day, once the information is taken to the Sigmafine, one of the biggest elements, I will say, benefits that we're going to have is pretty much bringing that information back to have an improvement in your measurements, in your equipment, if something needs to be replaced or something needs maintenance. They say that information needs to be understood by everybody from where it's coming and from where it has to be taken back for that solution. The other, and I will say today, one of the most important one is securing the data. Say how we are going to take control of that information, how that information is not available more than for the people that have the privileges, and it has all those locks to prevent having that information being accepted for unwanted people. And at the end of the day, I will say the most important part is the return of investment. How whatever we have done is able to produce financial benefits for our companies. And here in somehow this slide that I'm going to pay more attention, and the implementation of the Sigmafine is integrating that data. So for us, in a typical scenario for our system, well, we have in the supply chain part the different components that are around our Sigmafine. They say we can start talking about planning, the scheduling part, the execution part. They say all this part of custody meter information that is coming to our system. I will say we can have even additional components like the maintenance system that can give us some information related when we have shutdowns or we have some equipment that's out of service, and that information can come to our system. And pretty much dynamically in the Sigmafine, we will be able to put out of service a component, a valve, close it, open it. All that information can be actually automated. And that's the intention of what we have envisioned with the integration framework, to be able to collect that information from the several systems that are around or Sigmafine and have that information, I will say reducing time to collect all that data. I'll say the beginning, I will say in the initial steps of integrating Sigmafine, very much I'm sure that you have used it before, that we have the data importer and we have the data loader. That was traditionally the way to import data directly to the Sigmafine, where we used to go there, fill our or Excel sheets or CVS files and import that data to the Sigmafine. The idea is that still works, but what we want to do is pretty much to reduce that time. Instead of having our teams filling that information, the idea that our system, using the integration framework, should be able to collect the data directly from the data sources. And I will say in this sense, we have, let's say, prepared this small truck that in somehow is our integration framework, that our idea is to have this like the media to collect the data from the different data sources and put it ready for the Sigmafine. And one of the most important thing is the flexibility that our tools have. They say we know that, well, that is very important to have a way that is seamlessly integrated with our solution. I will say the integration framework provides a native integration with the PI system, also with our Sigmafine, where with this, I will say with the configuration of the data reference that we have, the people that is using traditionally the Sigmafine, they don't even know from where the data is coming. There is no transformation of the way that you do your business, but the data is coming to our Sigmafine modeling. I will say the use of the coding is really minimum. It really depends of, I will say, of the complexity of the business rule that we need to implement to import that data. And I will say here is exactly the question that you were asking us, Rich, about, for instance, from where the data is coming. Do I know that that data is right? Let's say I will see in one of the next slides how we can really trap that information at the beginning when the data is collected, and we can identify many things, like for instance, if our data sources was down, if the information that is coming is incomplete, or that information, for instance, doesn't match with our master data. And that information in somehow, it is not really rejected, it's consumed as much as possible, but it's always highlighted what is happening. So the IT team immediately can take actions and go and solve any problem that is identified immediately. So here in our architecture model of what it has the integration framework, you can see very much an identification of, they say in the top part, the integration with the enterprise systems. One of the most important parts is, for instance, when we are preparing our plan data that supply chain information is coming, let's say all that system can come in the, let's say from SAP where the plan is coming down, so the Sigmafine is able to receive the data through the integration framework using the SOA middleware communication layer, but also it keeps the connectivity, the typical connectivity with our traditional data sources, for instance. We have the connection to relational databases, or it can be also, they say, OPC systems. All that data is able to be connected using the proper connectors that the Sigmafine provides. Yeah? And of course, it has the possibility to integrate, say, customized integration rules to take decision of how that data is going to be taken and transformed to our systems. So in brief, we can summarize that. What is the integration framework? They say integration framework is pretty much a configurable engine that's capable to integrate heterogeneous system to the Sigmafine. And is able to bring information from different types of sources, like relational databases, operational systems, text files, Excel sheets. I will say also from real-time databases. And its modules that they use, it has basically integration framework server, the integration framework connector that are pretty much those dedicated to import the data, the configurator, that's pretty much the tool that is used to develop the interfaces according to our needs, and the data reference, that is pretty much the way how the data that is in the integration framework is exposed internally in a Sigmafine model. And I'll say, and as a part of the challenge that we try to fix or to tackle in the implementation of Sigmafine, will say, it's pretty much a big list that we have here. They say, first, to solve the problem of collecting data. They say that data is coming from external systems, so we should be able to have I will say eventually the connectivity to relational databases, to file text, to also to OPC systems, all those, and also middleware systems. The synchronization with the data that is pretty much associated, for instance, what I was mentioning before, like in the case of maintenance information, where I can bring exactly the data and the current conditions. And I will say current conditions can be position of the valve, but it can be also, for instance, lab data with information that is coming from I will say, densities, BSW, all that information that is associated to a case, but also to a specific time that we need to receive it. And exposing data, we have in many ways how is that the Sigmafine is able to import information from the external system and ERPs, but also how to export that data. And in that sense, what is able to send it back to relational databases using the SOA middleware part, but also is able to write back to the PI system, as Sorry was mentioned. And other part, we have reporting, integration. We have the notification based on some triggers that can be associated depending on a specific condition that the model can have, of some of the behavior that we can have, publishing that data back, and also posting that information in the sense that we can be able also to produce XML files that will be possible to be collected from our SAP systems like traditionally done in certain areas. And the technical specification about the elements of the Sigmafine regarding how the data flows, they say we have the connectors that pretty much, I'll say in the typical cases, from the around 50 implementation that we have done, many of the cases is always to relational databases. It can be, let's say, we have done it for both for SQL Server and Oracle using OLEDB or ODBC connectivity, but also in interconnection with text files, let's say CVS, XML files, and web services for a future project that we are planning to have in South America is expected to receive data from a web service for a metal mining implementation over there. And well, services, we have pretty much how it is connected and the triggering of that information, how we can launch some specific steps in, I would say, in the validation of the data, but also how that data is exported and exposed to the system. And the scripting part is very important from the way that how complex or I would say, or how complete our interfaces can be. They say, as I mentioned before, it's pretty simple to have an initial interface, but the system is also able to implement a very complex analysis to the data that is received and take decision on how the data is propagated to the Sigmafine. Just to give a brief example, for instance, the typical process of the integration framework is collecting the data, it depends, let's say, for a text file or for a relational database, and then the first steps, that is pretty much the mapping of that data, depending on from the system that is coming, but also, as you can see, have the synchronization of taking decisions of one of those, exporting the data to Sigmafine, but also to keep a track of what we have done. So if there is a detection of an error, data that wasn't properly transformed, all that information can be logged. So in the moment that you are importing the data, you can have a report that is also telling you what's going on. Did I receive all that information? Do I need to do a specific check of the data that I got? And all that information can be just checked over there. And here is just a brief an example how you can have, for instance, the transfers of the movements and how that data needs to be mapped to our system, and then the set of records that is going to be imported to the event area for our Sigmafine for very much the case analysis of that day. And some case studies, I will have, I have just take few of them. The first one is one case that we have for Slovnav in Europe. And I will say the most important thing that I got from that case was pretty much the effort that they were spending about collecting the data. And the reduction of time using the Sigmafine was quite significant for their implementation, that I will say it is one of the most important parts that I will always pay attention in the implementation of a project. That is pretty much that reduction of time. I have cases, for instance, in Latin America, where in the initial stages in conversation with our clients, I have found that they tell me, sorry, but it takes me 8 hours to complete the analysis before we start in the project. And very much after the implementation, we have reduced that work to 2.5 hours from the beginning of collecting the data until the completion of the reconciliation process. I will say, regularly, this is the first thing that the people want to say. We just want to reduce the time because the validation of information is quite complicated. It's coming from different places, and there is a very complex part to compare from where it's coming and what is the data that is missing. The other case here is about an Orpic. The Orpic is a company that is located in Qatar, in Middle East. And on Orpic, pretty much, it has a very complete implementation where we have all the different areas of the supply chain. They have the planning scheduling part using product from AspenTech, and then they use also our IMM, the Intelligent Movement Management component, that is pretty much that one that collect movements and transfers from the field, and the Sigmafine. So all this process and data coming from the different systems, and at the end of the day, sending the data back to SAP is using our integration framework. And another one that we have, the Petrom, this is a refinery that is in Romania. And it's pretty much here just to show you a comparison related of how they were able to receive also the planning data from two different purposes. Once I have the plan, I'm really able to compare the information that is coming from instrumentation. So I can do two things first. First, to have a validation of my data when it's getting received, and seeing if I'm really close to the expected behavior. But the second thing, to do analysis for the KPIs, how well my units are producing. So as a conclusion, we have that integration framework for us is pretty much the right tool for the integration of the Sigmafine, for the extensive set of enterprise applications that you have. And I will say one of the biggest advantage is pretty much how simple is it to use it, and how well integrated it with the Sigmafine. And I will tell you that during the day you will see more cases for our clients using the integration framework, and now pretty much the intention was to have an idea what is going on behind everything that you will see and why they are working so well.